What if the emergence of humanity was triggered not by Earth, not by climate cycles, but by a silent gravitational brush with a passing star? This isn't a metaphor or speculation. This is the core implication of a new study by Avi Loeb and collaborators, just accepted by Nature, and it forces us to confront the possibility that a stellar flyby, one that occurred 2.5 million years ago, reshaped the solar system in a way that directly intersects with the moment early humans appeared. The star is HD 7977, an ordinary-looking star that may have done something extraordinary. Plunged close enough to the Oort cloud to destabilize the deep reservoir of icy bodies surrounding our solar system and send a burst of comets inward. The numbers alone should make anyone stop. HD 7977 passed between 2,300 AU and 13,000 AU from the Sunday. Even the furthest estimate places it within gravitational striking range of the Inner Oort Cloud, the massive, largely invisible swarm of icy nuclei that astronomers believe surrounds the solar system out to nearly 100,000 AU. These are the primordial leftovers of the solar system's formation, the dirty snowballs Fred Whipple described in 1950. They typically remain in cold storage, orbiting the Sun far beyond the reach of the planets, but they are extremely sensitive to passing stars. Loeb's team modeled the flyby, and the results are stunning. HD 7977 didn't just nudge a few comets. It likely repopulated the Inner Oort Cloud, altering cometary orbits on a solar system-wide scale. The distribution of angular momentum among Inner Oort Cloud comets shifted dramatically, with many objects being pushed into elongated trajectories, capable of bringing them into the inner solar system. And the most critical number emerges from the closest approach scenario. The probability of 1-kilometer comets hitting Earth increased by an order of magnitude. This isn't a minor uptick. This is a systemic disruption. The timing is even more shocking. The simulated comet shower peaks at 2.47 million years ago. That is precisely the time Earth shifted from the warm Pliocene into the harsh glacial cycles of the Pleistocene. This transition was abrupt, global, and transformative. Ice sheets expanded, sea levels dropped, ecosystems reorganized, and, most importantly, early humans emerged during this period. The chronology is almost too well aligned to ignore. For decades, the Pliocene-Pleistocene transition has puzzled geologists. Traditional explanations focus on tectonics and ocean circulation, but these mechanisms don't fully explain the abruptness of the shift. A comet shower, even one consisting mostly of atmospheric explosions rather than surface impacts, could inject dust, aerosols, and water vapor into the atmosphere and trigger cascading climate effects. And because comets are fragile, volatile, rich bodies, many may have disintegrated before reaching the ground, leaving minimal crater evidence. This is exactly why Loeb emphasizes that the Moon may hold the real proof. Unlike Earth, the Moon does not erase its scars. A spike in lunar cratering around 3 million years ago would support the comet shower hypothesis. We don't have that data yet, but its absence is due to a lack of targeted searches, not contradicting evidence. The structure of the Oort cloud makes the scenario even more plausible. The Inner Oort Cloud acts as a feeder for the outer cloud. Strong perturbations at the inner level propagate outward over time. HD 7977's flyby wasn't a single impulse. It was the start of a long, dynamical echo. The reshaping of comet orbits can persist for hundreds of thousands of years, leading to multiple waves of inward-moving bodies. What makes this more than a scientific curiosity is the direct link to human evolution. Environmental stress is a fundamental driver of adaptation. A prolonged period of climatic instability driven or amplified by cometary influx could have opened new ecological niches and pushed early hominins toward rapid innovation. If even a fraction of the Pliocene-Pleistocene climate transition was influenced by comet-driven environmental effects, then humanity's emergence is connected to a celestial event no living creature witnessed. Loeb's reflections, at the end of his article, deepen this point. He describes standing among sculptures and watercolors of great scientists, works gifted by artist Greg Wyatt. As he explains, creativity in science mirrors creativity in art. Both require the ability to imagine what lies beyond accepted boundaries. Just as Galileo's watercolors were the first realistic depictions of the moon, Loeb's dynamical modeling of the Oort cloud invites us to rethink the invisible architecture of our solar system and its influence on Earth's biological history. The boundary between science and art, he notes, is often blurred at the frontier of knowledge. This leads us back to the central question. Did HD 7977 trigger a comet shower that influenced Earth's climate and the rise of humans? Loeb does not claim certainty, but he demonstrates a plausible mechanism supported by gravitational dynamics, timeline alignment, and the known structure of the Oort cloud. The theory does not require new physics or speculative objects. It requires only a star passing at precisely the distance HD 7977 did at exactly the time it did. And that is the most unsettling part. If HD 7977 had passed slightly farther away, this episode might never have happened. If it had passed closer, the consequences could have been catastrophic. Instead, it passed at the distance required to perturb the Oort cloud without wiping out life on Earth. This is cosmic roulette, a gravitational coincidence with evolutionary consequences. We exist not just because of Earth, not just because of biology, but because a star brushed past our solar system millions of years before humans ever looked at the sky, a random passerby, a silent trigger, a gravitational fingerprint left on the icy debris at the edge of the sun's domain. The universe didn't simply allow humanity to appear, it may have helped set the stage. And this story is far from over.